So today, let's talk about the second half of, so our activity. We did that calculation, if you remember. What was the end thing we found? Total, yeah, the expected mass of what specific? Do you know? Yeah, a substance. Does anybody remember what substance? Silver chromate. Yeah, silver chromate. Let's write the second half of this equation. So I'll have sodium nitrate or silver nitrate plus sodium chromate will equal silver chromate. Oh, S. Yeah, get out your notebooks.
You did not make the same mistake.
AG2? Yep. And if you remember, or you'll have that, we have something that looks like this probably. I'm going to start with just the first line. What did we put right here? Yeah, AgNO3, 13 grams of AgNO3 or silver nitrate. Today, we're going to do the 13 grams of sodium chromate. So we're going to start with 13 grams of sodium chromate today. 13 and a half, excuse me, 13.5 grams of, and I promise you, the more you put down this extra stuff, so I know I have 13.5, but if you put grams of sodium chromate, it makes it magnitudes easier. So we're starting with sodium chromate today instead of silver nitrate.
Is that CrO4?
CrO4. In the other room, you might have put 5.1 grams of silver nitrate instead of 13.5. So you did this twice yesterday. Some of you did this twice yesterday.
So you want to have a question of
Do you have a question? You have a question? No. It's 13 and a half. Yep. 13.5. So write down what I have on the board. A long line. Give yourself plenty of room. That way, on the right side of your paper. Because it gets quite long. Can get quite long. Okay, so what do we put next? We want to get rid of grams of sodium chromate. How do we get rid of grams of sodium chromate? What has to be in the bottom? Grams of sodium chromate. So if we want the top to cancel out, we have to move to the right and put whatever we want to cancel. And so we have to compare items. I can't go 13, or I can't put the atomic mass of sodium chromate down here and then put the atomic mass of, because we're looking for this, of silver nitrate. I have to do comparing. I forgot a step, but we'll get there. So what's the atomic mass of sodium chromate? How do you find that? I'll do it for you. Yep, we did it. We did the other one. It's what? Yeah, you add them together. I'm going to do it for you just to make it easy. It's 161 0.97 grams chromate. Okay. One hundred 61.97, my 9 and my 7. 97 grams of sodium chromate. And when, because this is a dividing line. This line right here is dividing. So when you have a dividing line, those underneath can cancel out with those on top. So the grams of sodium chromate cancel out with the grams of sodium chromate. They cancel. What is the unit we use? It's a counting unit, we call it. It's a mole. We use a mole to count it. So if you didn't watch the video yesterday, I'll use the same comparison. So we use moles like we use feet. So instead of saying this room is, what's 20 times 12 is 200. Instead of saying this room is 240 inches across, we just say it's 40 feet. Or 20 feet. Ugh, bad math. So instead of 240 inches across, it's 20 feet. So it's a way of condensing the grams into countable. It's a way of condensing this into a countable measurement. So we'll say it's 1 mole of sodium chromate. Who doesn't understand? Okay, that's good. That's fine. So a mole just means 1 mole is the same as an atomic mass of something. So if I say, does anybody know what a ton is?
Yeah.
So instead of saying I have 6,000 pounds, I got 3 tons. I have 3 tons. It's the same thing. Instead of saying I have 161.97 grams, I have 1 mole. And I forgot a step. I forgot one step before we started. We got to balance this. So I'm not going to write it out. I'll do it for you. You guys know how to balance already. We got 2 sodium, so we have to have 2 sodium. Now we have 2 NO3, so we have to have 2 NO3. Now we have 2 Ag. Oh, we're good. Okay, so it's 1 or 2, 1, 1, 2. Okay, so again, we want these to cancel out. How do I get this 1 mole of sodium chromate to cancel out? You have to put it down here. These cancel. Again, we can only, what? Oh, so we got grams of sodium chromate, grams of sodium chromate. So these 2 cancel.
So just the labels that you cancel out?
Yes, just the labels. And because, well, if they were the same number, you could cancel both out, right? So if this was 169 or 161.9 and it was up here too, they'd cancel, but that's more of like a math thing than it is a science thing. I want you just to cancel the units. And it makes sense. There's a reason we do this. So does anybody remember what we can compare this mole to? It's actually just 1 today. Yep. So the reason I put 1 mole is because I looked up here at my sodium chromate. If I had a number right here, I would put that number. Well, it's 1. You just have 1. So I put 1. If I were to do silver nitrate, I would put a 2. It'd be 2 moles of silver nitrate. So I take this number, put it right there. And my units are moles of sodium chromate. Cool? So now what do we compare? What's our end goal? Does anybody remember? Grams of, and what's the solid that we found?
Silver nitrate.
Silver chromate. Yeah, you're on the right track. So this was in the liquid when we did the experiment. This was our liquid part. It was still in the water. That brown solid that we found was the silver chromate. So we're trying to find how much silver chromate we can expect. If the reaction happened perfect and we collected all of it, we can expect, well, we'll find out, this much sodium chromate, or silver chromate. Okay, let me backtrack. Let's come back to the problem. Guys, pay attention. So we've got 1 mole of sodium chromate, and we're going to compare it to our silver chromate. How many moles of silver chromate do we have? 1. And we can only compare moles to moles of different. So we can only compare moles of moles for different compounds. So that needs to cancel out because we don't want to end up with moles. We want to end up with what? Grams. We want to end up with grams. So how do I cancel out moles? Put it down. So we're going to do the same thing we did over here, but flip-flopped. So I want it in grams of, this says sodium, but silver chromate. So I'm going to put, so I want it in grams, but I want my moles to cancel out. So I'm going to put, for every 1 mole of Ag2CrO4, do they cancel? Yes. Cross that out. How many? And then, so we're going from moles to grams. How do you find the grams of the atomic mass? Yep, it's the atomic mass. And you'll talk about this much more in 2 years from now. So this is more of an introduction. So I'll give it to you. The molar mass is 331.73 grams of AgCrO4, Ag2. So this is what we end up with. This does not cancel because this is what we're left with. So all these canceled out, all those units canceled out, but we still have this. So that means I don't know how to describe it. So we'll multiply everything on top, and then we'll take a second number. We'll multiply everything on the bottom, and then we'll divide the top from the bottom. So let's multiply the top together. What's 13.5? Don't have to worry about ones because 13.5 times 1 means 13.5. 1, 1. So 13.5 times 331.73. Somebody do that for me. What's that? Say that one more time. Let's go 3.6. So I multiplied the entire thing on top together. And that's how I did it. Oh, yeah. So this is the atomic mass. For every 1 mole, we have the atomic mass of silver chromate. So that's the atomic mass. So if we multiply the bottom together, what number do we get? Yep. So if I condensed everything, if I multiplied everything on top, I get 1,478.36. If you multiply everything on the top, you get 1,478.36. Yeah. I mean, if you don't have to multiply them together, but if you multiply 1 times anything, it's the same number. You got 4, 4?
I got that at first and then I changed.
You got 4? Oh, and I wasn't listening. I'm sorry, I wasn't listening very well. He didn't say 1, he said 4. I'm sorry. So we got 4. What? Yeah, to the nearest tenth. Yep. Yeah. Oh, yeah, because you weren't here for that. Yeah, we don't. Did you learn about significant figures at your school? No. Okay, that's fine. We just do the nearest tenth. Hundredth. 10th, 100th. So nearest 100th. What? So what's the end goal? All right. So does everybody have this? All right. Shh. Come back up here. Does everybody have this? So if you multiplied everything on top, you get 4,478.36. And if you multiplied everything on the bottom, you get 161.97. Yep, you divide them because this line acts as a dividing line. Can anybody tell me? Oh. 27.65 is what I'm told. Everybody agree? Okay. So what's my units for it? Yeah, it's whatever we have left over. Everything else canceled out. It's grams of sodium chromate. Or I keep on saying sodium, I mean silver. G. It's not. Nope. You're doing it A, as an introduction to it, and B, Mr. McKenney is doing, you can call it an experiment, but it's not an experiment, because don't think of you as lab rats. But he's, yeah, don't worry about it. We're just going to do it. You're going to learn it. Not a problem. You don't have to memorize it. You don't have to do this on any evaluation. That would be mean to make you do this on an evaluation. What you've been doing. We'll do problems on that here in a bit. Okay, let me wrap this up. So what we found, what we ended up finding is how much solid. So from your experiment, we have that brown solid. If I put in 13.5 grams into 1 cup, and then this would be double, actually. So if I put 13 into 1 cup, then I would get out 27.56 grams of Ag2CrO4. Not including this. Don't worry about this number. This number would actually have to be double to get that. Don't worry about it. So, what did you guys do yesterday? No, not you guys, but the people in my class. What'd you do yesterday in the lab? Yeah. Yep. You weighed it you weighed your sheet of filter paper. Quiet. You weighed your sheet of filter paper with all the material on it, and then you scraped it all off, and then you weighed it again. What'd you do once you weighed the two? You got the two. One's heavier than the other. You subtract them because that's the weight of the filter paper, right? Because you got rid of the other stuff, and you're left with the filter paper. That means the difference between the two gives you how much you actually had. So in a perfect world, if I did the reaction all right, the reaction was perfect, this means I have to double it, right? If you have a 2, you have to double it. So I had 27 grams of silver nitrate, then that means I would end up with 27.65 grams of silver chromate. Okay? So I had to run through that with you guys. Now let's talk about your quiz tomorrow. Good?
We're not having that on our quiz, right?
No. You're not having that on your quiz. You will have to do something with that on your own. Not on your own, but together, but with your own experimental values. So if you put in, instead of 13 grams we started with, let's say you put in 4.9 grams when you measured it out. You put in 14.9 or 4.9 grams. You start with 4.9 grams and you do this whole reaction or this whole process. But we're there to help you. We would not have you do this on your own. But this kind of stuff is your entire chemistry year. And 2 years from now, long ways away, I know it seems unreal, but this is the entire class. Looking forward to it. All right, let's move on.
Okay, well then what is going to be on the Is part of it vocab?
Mr. Wagner, me and Haley take the quiz right now. Well, not right now, after this class.
Yeah, I don't have it on hand, but
How long is it going to take? Like under 25 minutes?
I haven't looked at it yet. I think there's about 6 questions. It might not even been made yet. He might be working on it as we speak.
Yeah, I don't have the other account to get.
What chapter? Does anybody know what chapter we're on, just offhand? 24? 21, thank you.
It's Friday. Yeah, one day because.
Nope, no vocab. It's just what you've been doing.
Haley, isn't that behind?
Do we want to do some combustions?
It's like balancing.
Wait, we have a problem quiz this week.
A little bit balanced. What?
Do you have 9 quiz this Friday?
I'm going to take both of them on Friday.
Yeah, we have 2 quizzes. Okay. I'm going to give you... See...
I figured that one out a long time ago that I can't do that. If I could like snap my head out and then lick my elbow, then yeah, I could. Get your shoulder and try and bite your ear. I bet you can try and bite your ear.
Okay. Do this on your own first.
You gotta really reach back quick. How do I know?
Oh, O2. Yep. So I'm going to say it one more time. Final time ever saying it. You haven't been here. But final time ever saying it. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, right? What's special about them? It'll always have a 2 behind it. Yep, so when you have an oxygen, he'll put a 2 behind it. Where's my stupid marker? There it is. Okay, what do I write down? O2. CO2 or H2O, does not matter what order. Right? Good.
That's not gonna work. It's not gonna work.
Does somebody want to do it? You don't have to. I won't make you today.
What? Why did you say my name?
Don't let Michelle on here. She got a lot. I don't know how I did that.
I'm sorry, I forgot to record the answer. It is 1856. It was the answer. Okay. So for that next equation, it was 2, 19, 14, or 12 and 14. So 2, 19, 12, and 14. All right, so for our final equation, we're going to have HCl plus Li equals blank. That'll be a single replacement. Hey, welcome back. All right, so let's say I were to combine my hydrogen lithium. So I got hydrogen lithium, HLI. Does a +1 and a +1 cancel out?
No.
It does not. It gives me a +2. And that's not a happy ion or a happy chemical. Compound. Compound's the word. So I want the negative to be there. I want that negative to cancel out. Well, right? So if I put my lithium there instead, or my chlorine there instead of hydrogen, I get a +1 and a -1. Those cancel out.
One hydrogen cancel out though.
Yeah, we still have our hydrogen left, right? What am I missing here? 2. If you remember way back, it might be at the beginning of this chapter, or actually towards the end of last chapter, we want them to cancel out. We want our positives and negatives to cancel out if they can. This one won't because it's alone. So remember this. Our positive ions are going to be the one that's switching. Our positive lithium is switching with our positive hydrogen. Or the hydrogen's coming out and being on its lonesome. So what's the answer for this? 2, 2, 2, 1. All right, any questions? Oh, one last thing. Everybody pay attention, because I'll count points off. If I were to, let me get rid of a bunch of this stuff. So, if I were to do, instead of 2, 2, 2, 1, if I were to do 4, 4, 4, 2, does it still equal? It does. It still equals each other. But we want it to be the lowest possible answer. So if I were to put, 6, 3, 9 as my answer, you'd actually want it to be 2, 1, 3. 2, 1, 3. So you want it the lowest possible. So if it's divisible by 3, divided by 3. Divisible by 2, divided by 2. Hang on to it.
Wait, do you have a test made?
I can. All right. Goodbye.